Well, hey there, kiddos, and welcome to your video about slope-intercept inequalities. That's what we're dealing with today, our inequalities in slope-intercept form. We talked about slope-intercept form a couple days ago. Remember, it's the y equals mx plus b. And so the only different thing today is that we're dealing with inequalities instead of equations. And so we're going to have multiple solutions. So up here with Snoopy, under solutions to inequalities, we need to write a definition. A solution to an inequality is any ordered pair that makes the inequality true. And so whenever I am looking for a solution, that's what I'm looking for, ordered pairs that will make the inequality true. And we did this before when we did solutions to linear equations or linear functions. We had the ordered pair, we plugged it in, we tested to see if it worked. So like number 1 here, where it says identify 3 solutions to the linear inequality, they're just looking for values that will make this work. So what is great about this is that there are a whole bunch of them. I mean, there's a bunch of solutions to that inequality. We get to pick 3. And so we get to pick what values we want to use for x and then plug it in and see what happens when we plug it in for y. So if I plug in 0 for x, then what happens is I end up with y is greater than 0 minus 3. So I get that y is greater than negative 3. And so what I need then is a number greater than negative 3 that will make this work. Negative 3 doesn't work. If I put negative 3 here, that doesn't make a solution because negative 3 is not greater than negative 3. That won't work. What I have to have is a number that is greater than negative 3. So a number greater than negative 3 would be negative 1. If I put negative 1 right there, if I say y is negative 1, that is definitely greater than negative 3. So let's pick another value for x, and let's do that again. So now let's have x be, well, let's do 3. Let's say now x is 3, so I'm going to plug it in. Y has to be greater than 3 minus 3. Well, that means y has to be a number greater than 0. So in order for this point to be a solution, I need a number greater than 0. Well, the first one that comes to mind is positive 1, because 1 is definitely greater than 0. So let's do one more. Let's plug in one more value for x. So let's plug in 5. So let's do y has to be greater than 5 minus 3, which means y has to be a number greater than 2. And so a number greater than 2, anything greater than 2 would work. And so let's say 5. 5 is definitely greater than 2. That would make a solution. You could have picked 3, you could have picked 2.5, just as long as this y value is a number greater than 2. It becomes a solution, makes it work. So now look at B here. So you're buying paperback and ebooks from a place called Books A Trillion. Paperback books are $4.50 each, and ebooks are $2.50 each. You can spend at most $20. The question is, what are possible combinations of paperback and ebooks that you can buy? Well, the first thing we need is an equation to work from. So if this is paperback books, and this is the ebooks over here, then 450 times x plus 250 times y, and I can spend at most has to be less than or equal to 20. And so what I need are values of x and y that are going to keep me below $20. So I'm going to have to look for possible combinations that will make this work out. So I'm going to guess that 0 paperbacks and 0 ebooks would keep me under $20, because that would make this 0 and this 0, and 0 is definitely less than or equal to 20. So 0, 0 definitely is a solution. So now let's say that I bought one paperback book and 3 ebooks. I'm just picking numbers. So let's see if that keeps me less than or equal to 20. So I'm just going to pick up my calculator and do that math. 4.5 times 1 plus 2.5 times 3. That gives me $12. So this right here, if I buy that many of the stuff, then 12 is definitely less than or equal to 20. That is definitely going to be a solution. So now let's say I bought 3 paperback books. And 2 ebooks. So let's check that math. So I have to do 4.5 times 3 plus 2.5 times 2. And that has to give me a number that's less than or equal to 20. And when I do, I get that that is $18.50. And $18.50 is definitely less than or equal to 20, so there is another solution. You could guess and check and pick other ones if you want, but those 3 are definitely combinations of paperback and ebooks that I can buy and still be under my budget. So C then gives you a graph, and we are asked to find 3 solutions from this graph. Well, the solutions have to be in the shaded area. In this graph, they cannot be on the line because that line is a dashed line and not a solid line. If the line were solid, points could be on the line, but since it's not solid, points can't be. And so I've got to pick points. Well, this one right here is definitely in the shaded region, so I'm going to say 3, 0. This one up here is definitely in the shaded region, so that's 0, 8. And let's pick another one. Let's say this one right here. That's also in the shaded region, and if you look, that looks like it's at 7, 7. Any point in that shaded region, I could have picked points down here in the negatives, as long as it's in the shaded region. Nothing over here has to be in the shaded region. That's where my solutions are. So now this is the next part that you have on your notes. You have this part right here with all of these lines about boundary lines, dotted, solid. I want you to do this, and instead I want you to draw this chart underneath it because I find that this is much more useful. So pause for just a second, draw this chart, and then we will talk about what it means. So this chart is just, it's a reference for you for how to graph. So first of all, whenever you're going to graph an inequality, there's 2 ways, like we just talked about in C, that question C, to graph a line. You can have a dotted line or you can have a solid line. Dotted lines occur when you have just greater than or just less than as your symbol. A solid line happens if you have greater than or equal to or less than or equal to, so the points can be equal to the line. So that's where solid lines come from. Then the shading, because we always have to be able to shade where our solutions are. If it happens to be a greater than symbol, then you will shade up or above the line. And then if it's a less than symbol, you will shade down or below the line. And we're going to practice this, but this is a good reference for you to keep in front of you every time you're doing something with inequalities. So number 2, here we are. We're going to match an inequality to the graph of the solution. So I have 4 graphs and 4 inequalities, and I have to match them. So let's start with A here. It's y is less than or equal to negative 3x plus 3. So first of all, I know that because of this, it must be a solid line, which means it cannot be 1 or 2, because if you look at 1 and 2, those are dotted lines. So it's one of these 2, okay? I also know that because it's less than, it must be shaded below the line. If you look at 3 here, it is shaded up above the line. This is on top, and even though it doesn't really look like it, this is under the line, because if I point down this way, it's underneath the line. So it's going to be this one, but we want to check the equation. The y-intercept is at plus 3. The y-intercept for this one is not at plus 3. And you see it has a negative slope that goes down 3 and over 1. So this is going to be graph number 4. Which means that this one, D, is all going to have to be graph number 3, because it is the other solid line that has the greater than or equal to. I didn't even have to check anything else, but we can. Y-intercept of negative 8, and then up 1 and over 2 gets you to the next point, and it's shaded above for greater than. So now I have to do B and C. So we'll start with B. It is a greater than, which means it's going to be a dotted line, and it has to be shaded above. So this one right here is shaded below, and this one is above. So it's probably going to be number 2. But we're going to double check it. It has a y-intercept of 3, and then a slope of up 3 and over 2 for sure, which means this one has to be 1. So that's how we check it. The first thing I would always do is look for what kind of line is it supposed to be. Should it be dotted or solid? Where should it be shaded, up or down? And then I will worry about the rest of the graph from there. So like number 3 here, we have to write the inequality that goes with the graph. And so just like I told you, the first thing I always worry about is what kind of a line do I have? So it's always going to start with y. And this line is dotted, which means that it's just either less than or greater than. It doesn't have the or equal to part. It is shaded below the line, which means it has to be less than. So I have my symbol. That's the most important part. Then I have to do my graph, my equation. So my y-intercept is going to be at 6, so I know it's going to end up being plus 6 at the end, because remember we're doing mx plus b. So I found my b. Now another pretty point on this graph is right here. So if I do my slope, it goes down 2 and over 3. So I have negative 2/3 x plus 6. So there's my inequality for that one. So let's try b. Again, y. It's a solid line this time, which means that no matter what my symbol is, it's going to be or equal to, and it looks like it is shaded above that line. So because if I were at this point, it is shaded up. So that makes greater than or equal to because of the solid. My y-intercept this time is at negative 6, so I'm going to put a minus 6. Here's another pretty point. So I go up and over, and it looks like I went up 4 and over 1, so it becomes 4x minus 6. So there's that inequality. So what's the symbol? Is the line solid or dotted? And then find your slope and y-intercept. So number 4, a company uses the table to calculate the minimum price P to charge for an item based on the cost C of the materials. Which inequality represents the possible prices the company could charge for an item? The easiest way to do this kind of a problem is to plug in the points that you have. So I have values in this table. I'm going to plug them in and see if they work. So for this first problem, so we're just going to plug in these values and see which one works. So we're going to start with this first inequality. And where I'm going to use my calculator, but I'm going to write it down what we see. So P is 5, has to be greater than or equal to 2 times 1 plus 3. So I'll do that math. 5 is greater than or equal to 2 plus 3 is 5. Yes, that one works. You can't say that A is the answer yet, though, because this one works, but that doesn't mean that the rest of them do. So we have to check more. So the next one, 7. Greater than or equal to 2 times 2 plus 3. Well, 7 and then is greater than or equal to 2 times 2 is 4 plus 3 is 7. Still works. So then we'll check the next one. 9 is greater than or equal to 2 times 3 plus 3. So 9 is greater than or equal to 9. Still works. Check the last one. So I have 11 is greater than or equal to 2 times 4 plus 3. So 11 is greater than or equal to 11. That one works. So it looks like A is probably our answer. But because I am a math teacher and I have seen these kinds of problems over and over, I don't trust it. We're going to check the rest of them. So what I want for you to do is I want you to pause this video. I want you to grab your calculator, test the rest of them really quick, and make sure A is really the answer. So hopefully you went through and you checked and you did realize that A is the only one that works because of the way the symbols are written and what's facing what, because there's nothing different about any of the other inequalities except for the symbol. So A is definitely our answer, but that's how you do that. Plug in the values, see which one works, but plug in all the values, not just some of them. So last question here. A student with 2 summer jobs earns $10 per hour at a cafe and $8 per hour at a market. The student would like to earn at least $400 in a week. So we want an inequality first. So we have $10 per hour at job 1 and $8 per hour at job 2. And we want to make more than, less than, or equal to $400 because that's what at least means. So just like before, I need 3 solutions to this situation. Well, the obvious and easiest one So one of the obvious and most easiest ones is if x is equal to 0, so I don't work any at the cafe, then I can work 50 hours at the market. Because if I do that, 8 times 50 equals 400, and that falls into my problem. Another obvious answer is if I didn't work any hours at the market, then I could work 40 hours at the cafe. That would still get me equal to 400. Now I need some number in between there, so let's say that I work 20 hours at the cafe, and then I work 40 hours. That's a lot of hours to work in a week, but I work 40 hours at the market. If I do that, it's definitely greater than or equal to $400, and so I have met my situation. I'm good to go. So there are 3 solutions, although that student needs new jobs because that's a lot of work, and either that or they need to make less money. Now I'm going to graph the inequality, which is this inequality right here. This 10x plus 8y equals 400. So I'm going to rewrite it. And before we graph it, here are some things that you need to know. You can't graph it until it says y is by itself. So the first things first, I want to get y by itself. So I'm going to subtract 10x from both sides first so that I can get rid of that x. So I have 8y is greater than or equal to. Now I like my x term first. So I'm going to put negative 10x plus 400. Then I have to divide everything by 8. So I'm going to divide everything by 8, and so I have y is greater than or equal to, well, negative 10 over 8 doesn't divide into a nice pretty whole number, but it will simplify. I can divide it both by 2, and I can get negative 5 over 4x. Now 400 divided by 8, I'm pretty sure is 50, because we just did that a minute ago with the solution we were doing, and so that comes out to 50. So now I can graph this. Remember, we begin with the b, so we'll start at the y-intercept of 50. And then my slope is negative 5 over 4. Now here is the problem. It's really not a huge problem. But my problem, my y-axis here counts by 5s. That's great, because when I go down 5, I only have to go down 1 space. But it goes by 5s on the x-axis too, and I only need to run 4. So you're not going to run all the way over here to the next line. You're only going to go over to almost the next line, because if you go all the way to here, you've run 5 instead of 4, and that's a different slope. So I have to go down 5 and over 4. And that is the only other point I'm going to make, because then I'm going to just take my ID or the straight edge of something, and I'm going to connect that and make my line. But before I do, I need to look at my inequality symbol. Right here, it's greater than or equal to, which means I get a solid line. It doesn't have to be dotted. And I connect my 2 dots, and I have my line, and then I have to shade. And so let's talk about why we only have positive values on here and you don't see the rest of your coordinate plane, the rest of the grid. The reason you don't have any negatives is because you're talking about how many hours someone's going to work, and like it or not, we can't work negative hours. It's not something that happens. So positive values are the only ones that make sense. So that's the only part of the graph we have. But to get my solution to this, I've got to shade greater than that. So I have to shade everything above, which is this direction. So everything up here gets to be shaded. And you don't have to color it in 100% like you saw in our pictures that were already done. You can just scribble, just like this. Any point in this shaded area or on this solid line counts as a solution to the inequality. So that is slope-intercept inequalities. We will practice some more of this when you guys come to class tomorrow. I will see you then. Have a good rest of your day.